Hey guys, for our project, we decided to tour the facility of ABB Athens. They produce medium to large size motors with NEMA frame sizes of 360, 400, and 440, with their largest market for naval and mining use. This facility specializes in producing electric motors as shown here. Here is the shaft before and after machining. Shown here, the blank metal disc is a lamination blank. This lamination blank disc was formed by cutting the disc out of a sheet metal with a die press. This blank then goes into the Schuler notching press. In this machine, slots are cut into the lamination disc one at a time in the notching press using a die specific to the slot detail. It is imperative that the slot detail is held to tight tolerances because this slot is then going to be die casted and injected with aluminum. Sheets with slots are stacked onto an arbor and inserted into the die-cast machine where molten aluminum is shot into the rotor and fills up the area inside the slots that were just cut out. A keyway is extruded into the inner diameter of the rotor to align it radially. Stator lamination sheets are stacked on top of the arbor. Stator laminations are produced the same way the rotor laminations were described in the compound blank and Schuler notch presses. Their slot details are just vastly different. Stator slots are open to allow for insertion of wiring later in the assembly process. An insulating paper material is inserted into the stator lamination slots to isolate the wiring from the metal exterior of the lamination sheets. Several automated robots wind copper wiring into the stator lamination slots on top of the insulation paper. This is commonly done in a three-phase orientation. Lead wires are connected to complete the circuit. Wire leads are fused shut after being connected. Wire spindles are pressed down further into the slots and wires are pressed together to save space. Is tied together to secure proper orientation after all the previous processes. Stator core is ran at max voltage and checked to make sure everything is functioning properly. Shown here is a finished stator core and is the product of the last animation video. Notice the blue insulation paper and the three phases of bundles in the copper wiring. The stator core is inserted in a varnish solution. This coats the stator core in one liquid and gives its surface all the same material and electrical properties. Cast iron frame is pulled and the stator core is pressed inside. A rotating assembly consisting of a finished rotor with a machine shaft is inserted into the inner diameter of the rotor lamination disc. Remember, there is a keyway present to radially align the rotor and the shaft. There are also bearings present on the ends of the shaft to eliminate friction on the mechanical work output of the electrical motor. This rotating assembly is inserted into the stator core of the motor. This is not a press fit as ample clearance needs to be present to allow rotating assembly to rotate. Cap covers of the frame, conduit box cover, and other miscellaneous parts are loaded and fed into the assembly. Operators manually screw everything together and finish the construction of the motor. Unfortunately, we were unable to obtain clearance for this section due to the privacy rights of the motor. Finished motor shells are spray painted to order.